Hello everyone. Today we are going to see how to implement a queue and its function. So if we're going to the program, we can see about queue. Queue data structure. Um, uh, Already we have seen stock. Stock is the order of last in first out. It is opposite of queue. While queue we get FIFO, that is first in first out. Here it's a queue. Then this is the rear end, that is tail, and this is the front end, which is head of the queue. So it's an example of queue. That is, a person in the front is the front of the queue, while a person is in back. It's the rear of the queue. What are the functions we are going to implement in this queue operations, such as adding an element, removing an element, and displaying the current values in the queue. So coming to operations on a queue, as we said, is full, that is determine whether the queue is full, and Enqueue is adding an element to rear of the queue, while empty is determining the whether queue is empty, and Dequeue is opposite of Enqueue, which removes an element from front. Enqueue adds an element to rear, while Dequeue removes an element from the front, and display prints the value of queue. So this is the front. Like stock, in stock top is initialized to -1. Same in queue, there are two things, front and rear. Both are initialized to -1. Front is -1 and rear is -1. While we are adding a value, front becomes a 0 and there are no values behind this A. So rear also 0, and again we are adding a second value. Now rear is 1 because we added an element to rear, that is Enqueue. Yeah, same like this we are adding up to C, while here we are removing from front, that is from A, B, C. This is called DQ, that is entry point is rear while exit point is front, and these are the algorithm of isFull and Enqueue, while algorithm of isEmpty and DQ function. We can see the program now. To create a queue and implement the functions Enqueue, DQ, and display. So we are coming to stock. First, we are creating a stock. That is, we are getting the size of queue and declaring an array that queue and initializing front and rear to -1. This is the basic uh, algorithm for queue implementing. Yeah. First, we are created. First, we are getting the size of the queue. Then I am declaring an array queue for the size. Then I'm giving front and rear, that initializing -1. So we have created a class queue. Then we are checking whether the queue is empty, and we are also checking whether the queue is full. So first we are giving global max, that is size, and the queue, that is the queue, and the fr, that is front and rear. If f is equal to -1, it is empty, otherwise it is not empty. Same like in full, if r is equal to max -1. For example, if we take max as 5, 5 minus 1, we are getting 4. So there is remaining 4 elements in the cube. So it is a the queue is full. So r rear is equal to max -1. Yes. So coming to main function, do Enqueue. Do Enqueue is incrementing a value to rear, that is inserting a value to rear end of an queue. So I'm defining Enqueue for operation, and I'm defining the max queue, all the queue and its elements. Now first, if it is full, print queue is full. If the queue is full, we can't insert an element. So first we are checking whether a queue is full in the Enqueue operation. If it is not full, we are incrementing one value to rear, that is Enqueuing and value. So we are assigning n to q of r, that is rear of q. So nq's opposite is dq. We know that we are removing an element from front because it is first in first out. So we are declaring all the variables max, q, size, declaring that array name and front and rear. In this we are going to check empty. If the queue is empty, no elements cannot be removed. So first of all, we are checking the queue is empty. If it is not empty, then we are going to remove the one element from the front of a queue, that is q of f. So incrementing value, returning f. That's all. Then at last, third function is display. Now we are displaying the current function of what is in the queue. That is front, same like we are displaying, and rear end we are inserting an element. So we are giving that r plus 1. So I'm printing the queue. Then next we have to create a menu driven function, like we have to get the input from the user. So we all know while is used to execute a block of statements. So while one print enqueue, dequeue, display, break. So I'm getting the choice. If user choice is one, an element is inserted. If user choice is two, an element is removed from the front of a queue. Then if the element, if the user choice is three, we are displaying the elements. Then we are ending the loop. Now I'm executing the statement. I'm giving three as the size of the queue. Then I'm entering the choice. My choice is enqueue, that is inserting an element to rear. Then I'm giving, for example, I'm giving three values. Three. Again, I'm inserting enqueuing. I'm giving six, and last value I'm inserting. So I'm giving a choice as one and giving the value as eight. So now I'm dequeuing. That is, I'm removing the element. If you remove the element, the three will be get removed because three is in the front of the queue. Let's give two and see whether three is removed or not. Yeah, see the removed showing is three. So finally, I am giving display. Yeah, the values are getting displayed. Remaining values are 6, 8. So at last, I'm finishing the execution of this program. Yeah. So first, we are creating a stack and we are checking the function is full or not, and we are checking the function is empty or not. And the fourth step, we are enqueuing element, that is inserting an element to rear end of a queue. Then fifth step, we are dequeuing element, that is removing an element from the front of the queue. Then finally, we are displaying all the values in the queue. So the queue data structure is created and functions such as enqueue, dequeue is implemented. Thank you.